Okay, in this video we're going to look at what's called the fundamental theorem of calculus. Sounds pretty important, right? Well, it is. This is a way to evaluate definite integrals algebraically. So far we have looked at ways to approximate definite integrals. We said we have Riemann sums to do that. We have the trapezoidal rule to do that. Those were ways of approximating the area under a curve, which we know can be represented as a definite integral. And then we looked at geometrically, if we were able to find the area of a recognizable geometric shape, such as a triangle, a trapezoid, a semicircle. We said we can find the area under a curve that way. But of course, we were limited to just certain kinds of functions, right? Ones that produce those certain kinds of shapes. So now we're looking at an algebraic way to find the exact area underneath the curve. In other words, to evaluate a definite integral. And it doesn't matter what the function is. Okay? So it involves what we just did in our last video, which was finding a basic antiderivative. Okay? So if we were to find the antiderivative of our function, we're going to call the antiderivative capital F. If we were to then plug in our bounds, beginning with the upper one, and then subtract the lower one plugged into the antiderivative, we would have the value of our definite integral. So let's see this in action. Alright, suppose we were to evaluate this definite integral from 1 to 3. We have x squared with respect to x. So take a moment and sketch this drawing. So of course we're trying to find that blue shaded region. Now if we went to our calculator, okay, our calculator would tell us that this area is 8.6 repeating, alright, which if we convert that into a fraction, we're looking at 26 over 3. So this is the exact area under the curve. That 8.6 is not exact. Of course, 26 over 3 is. So that's our exact area. Again, we got that just using fn int. So let's show how we can use the fundamental theorem of calculus to get that 26 over 3 number. So the first step here is to find the antiderivative of our function. So we have x squared. So what we're going to do is apply our power rule, which says we're going to add 1 and then we're going to divide by 3. So we've just found our antiderivative. Now what we need to do is somehow carry along the bounds from 1 to 3. Well, the way we do that is we draw either a vertical line, or typically I like to use a bracket. Alright, and then we're just going to write the bounds 1 and 3 at the top and the bottom like that. So this signifies that we've already found our antiderivative, but we have yet to plug in our bounds. Notice how I've dropped the integral symbol. I've also dropped the dx symbol because I have found an antiderivative. So from here, typically I like to say things like draw a parenthesis minus a parenthesis. Okay? So this shows that first we're going to, now remember the fundamental theorem of calculus says we're going to do f of 3 and then minus f of 1. Remember, capital F is our antiderivative, so we're going to first plug in our top bound. Alright, so again, get in the habit of doing a big parenthesis minus a big parenthesis, and then we're going to just fill in whatever we need to fill in. So what this is going to look like is first we're going to drop a 3 into this equation, right? A 3 into this antiderivative, and then we're going to drop a 1 into the antiderivative. Of course, the order matters since we are subtracting, and we know subtraction is not commutative. So from here, we have 27 over 3 minus 1 over 3. And hey, look at that. When we clean it up, we get 26 over 3, which matches what we already knew from the calculator. Okay? Of course, we're not always going to be allowed to use a calculator. Now, finally here, I want to point out a very, very, very common mistake that I see time and time again. So if we go back to this first part here, here is what I see. Alright, I see people doing this. They say, okay, they know they're going to have to do a big parenthesis minus a big parenthesis, and then what people tend to do is they do not find the antiderivative, and they just do 3 squared minus 1 squared. Okay, so this is not equal to that. People tend to forget to find their antiderivative. Okay, so beware. Okay, please make note of this. Again, it's easy to think, well, that would never happen to me. Well, trust me, for some reason, once the functions get a little bit more complicated, people tend to forget to integrate. So we have to find our antiderivative before you could then plug in your bounds and subtract. Okay? Bye-bye.